supposed to submit the tutorial too.
No, you, as I said, tutorial is only for your practice. You only have to submit the assignment.
Sir, where can I check my result, sir? For assignment one?
Go to Moodle and try to explore. It should be there.
Okay, sir.
Okay, now also one thing I wanted to say was that for your benefit, in the first assignment, the tolerance was not taken to be 0.02, but I think it was taken to be 0.04. Okay, is this
Yes, sir.
is a slide visible?
Yes, sir.
Yes, sir.
Yes,
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. So what we are going to do is I have divided the problem sheet into groups of similar problems, okay? Similar types of problem. So we will solve one type of every problem, and please everybody should try to make sure that you at least solve that question within the tutorial itself. If you are fast and if you finish that question quickly, then you can go to other questions which are of that type. Understood now how we are going to do this tutorial? Everybody clear to everybody? For example, question number 3, question number 4, and question number 8 are similar. They are based on the same concept. So we will discuss one out of these 3 questions, and I expect everybody to do that question. If you are fast, or if you have already done question number 3, let us say, you should try to attempt question number 4, question number 8. But everybody should at least finish question number 3. That way, out of 11-12 questions, we'll finish 6 or 7 questions in this tutorial itself. Your load outside of the formal class will be very little. Okay, let us try to conduct our tutorial class in this format. Is this format clear to everybody?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so question number 1, question number 2 are about free body diagrams. They are very easy questions. So what I have done is a slightly more complicated problem for the free body diagram I have projected in the screen. This was part of a exam, I think 2 or 3 years ago. So read it carefully. Try to draw the free body diagram of member ABC.
Sir, can you
And
shift to
just
presentation mode? I can't see the values from here.
you don't need the values to draw the free body diagram.
Okay, free body diagram only. Okay.
Yes, only the free body diagram. We want the free body diagram of this member, ABC. Read it carefully and try to answer this. If you are able to draw the free body diagram of member ABC correctly, then more or less you can be confident that you have understood the concepts of free body diagram sufficiently. If you don't understand the language, or if there is any question about this question, then let me know. First, read it carefully.
Sir, ABC only.
Only ABC, yes. ABC is only difficult, the rest are easy. So just focus on ABC.
Yes, sir. Done.
I am going to explain what the catch is. Okay, why this
So
problem
done.
So done.
1 minute. So control P. So this is difficult because of this. You have to keep in mind this one. This is the most important phrase. Frictionless slot. So this length is not infinitely small. Okay, keep this in mind. Draw the free body diagram of ABC. I am projecting 4 choices. Number 1, 2, 3, 4.
Sir, excuse me, sir.
Yes.
No, sir, no, it's fine.
And indicate which do you think is correct.
First choice.
The bottom left.
So can you take the page a little back, means previous
Number
page?
two, I think. Two.
Number 2.
Number 1. Oops.
Please, I have typed the message. You can
Number
Sir,
1.
number 2.
you
Sir,
can
number 2.
if
Number
everybody
one.
speaks, it will be if everybody speaks, it will be difficult. Please indicate your choice. I will tell you the correct answer. I have written 4 messages. Please hit like on the one you think is correct.
Can you show the
Please show
choices
the
once again?
Yes. Now you can see the text and the choices.
Sir, where is number 1 in?
This is 1. 1, 2, 3, 4. In red color, I have written. This is 1, for example.
Sir, option 3 and 4 are the same just because of the direction.
So if you think more than one option is right, you can choose more than one also. Okay, so if you have chosen option 3, it is wrong. If you have chosen option 4, it is wrong. Option 2 is right, option 1 is right, and option 1 and 2 are actually equivalent. Has everybody understood this, or you want some more explanation on it?
Yes, sir. Yes.
Please explain why it is.
Sir, please.
Sir, can you please explain?
Sir, in 1 is there is movement and in 2 there is not movement.
Yes, but N1 not equal to N2.
They are interconvertible.
Force
I
couple
mean,
system
yeah,
you can use.
they are equivalent. That's what I mean. I did not say they are the same. I said they are equivalent.
Sir, didn't understand the reason for the moment.
Okay, let us do this. Okay, you can do this experiment in your home also. Do something. Take 2 books. Okay, take 2 books. In the middle of the 2 books, put a pencil, which is I have put in yellow color. So this is finite. This blue is having finite length. This yellow is your member ABC, let us say. Okay. Now, tell me that whether this movement is allowed. Will this bar be allowed to penetrate my support and go like this? Yes or no?
No, sir.
No, sir.
No. Okay, good.
No, sir.
No, sir.
Will it be allowed to go like this?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, good. Yes, sir. Now, is this allowed?
Yes, sir.
No,
No,
sir.
sir.
No, sir.
No, sir.
No, sir.
No, sir.
It is not allowed. Okay. So what can we say about the free body diagram?
Perpendicular force plus the moment.
It is constrained in the horizontal direction.
So we can let us do this.
So there are 2 constraints.
So we have a perpendicular constraint like this, and we have a
Sir, I have a question.
moment like this. 1 minute. Let us finish this. Okay. Is this now clear? Why there should be a force and a moment?
Yes, sir.
This is
Yes,
option 1. This is option 1. Now let us try to reinterpret this. So option 1, why option 1 is correct? Everybody understands?
Yes, sir.
Yes, sir.
Yes, sir.
Now,
No,
let
sir.
us
How
look
did
at
two forces?
Sir, why is there only one
Yes, sir.
force? There should be two
Because-
forces.
No, because it is not going to move in both the directions at the same time. Na? This is like a roller. In a roller also, both the upwards and downwards movement is taught, but we have only one normal force. Okay, now imagine that now imagine that a small rotation is allowed because of the tolerance. The slot is not fitting perfectly, but a small, very, very small tolerance, very, very small rotation like this is allowed. Then what are the constraints? I am magnifying this. This is not drawn to scale. Imagine that due to the fact that it is not perfectly fitting, a very slight rotation is allowed. If that very slight rotation is allowed, can I say that the free body diagram now will be that there is a normal force here?
Sir, it is very
And
difficult to
there is a
hear.
normal force here.
Sir, sir, some
Wait.
background
Yes,
noise is
sir.
coming, sir.
Yes, sir. Some background noises are disturbing.
Now it's okay. I think somebody's mic was not.
Yes, sir. Yes,
Okay.
sir.
Yes, sir.
So can you see the orange lines that I have drawn? Orange arrows?
Yes, sir.
Yes, sir.
Right. Right.
Yes, sir.
So imagine that there was a very small tolerance. This is zoomed in. If you zoom inside, maybe the stick is allowed a small rotation. After that, it is not allowed. Then my constraints are in this direction. Yes? Or not?
Yes, sir.
Yes, sir.
And
Yes, sir.
this angle
Yes,
is very
sir.
small. This angle is very small. So it's almost 90 degree. So will my free body diagram look like this in that case?
Yes, sir.
This is option 2.
Yes, sir. Yes, sir.
So and why is option 1 and 2 similar? Because look, N1 not equal to N2. Okay. If N1 not equal to N2, N1, N2 can be replaced by a force NA and a moment MA.
Yes, sir.
Yes. So 1 and
yes,
2
sir.
actually are equivalent. Both are correct free body diagrams. 3 and 4 are wrong. 3 and 4 would be right if it was infinitesimally small length. If it is infinitesimally small length, then you have this situation. That let us do this. If this is infinitely thin, then what can you say? Then is this rotation allowed?
No.
Yeah. Yes,
Yes.
sir.
Yes, sir.
Yes. If it was
Yes, sir.
infinitely, if
Yes,
this
sir.
suppose
Only one horse.
do not have finite
sir.
length, they are infinitely small, then this is
Then
allowed.
there is
Then
only
3
one
and 4 would be
constraint.
right. Then option 3 and 4 would be
Yes,
right.
sir.
Yes, sir.
Okay, good. So I think if you understood this, question number 1 and 2, you should definitely be able to do. This is much more complicated than question
Sir, I
1
had a
and
question.
yes.
Sir.
Sir, I had a question number 2.
No,
Sir,
wait.
I
First
was
question
saying,
will ask first. One at a time.
sir, I was saying in the freely guided slot, there also rotation is not allowed. So why don't we consider a moment there?
No, no. In a freely guiding slot, rotation is allowed. Wait.
But it's kind of the same thing, no?
No, wait. Stop sharing. Where is freely gliding slot? 1 minute. I am searching for the slide where freely gliding slot is described. Okay. Is this slide visible?
Yes, sir.
Yes.
Yes.
Now,
Yes, sir.
this
Yes, sir.
member is allowed to rotate. You will only draw free body diagram of this member.
Okay.
So there is a slight difference. Okay.
Yes, yes, understood.
Good. Anybody else had any questions?
Sir, I had a
Sir,
question regarding problem 2 in tutorial sheet 2.
Problem 2 in tutorial sheet 2. Yes,
So that airplane one.
correct. Huh?
Sir,
There is
that question I cannot find, I cannot understand how the equilibrium will be achieved, since if we draw the coordinate system keeping the x-axis along the line in which t and r are present, then the perpendicular component should be 0, but weight is vertical and it can never be 0. So I cannot understand how can we achieve equilibrium in that airplane situation.
Aircraft of WB constant thrust is only
Yes,
a
sir.
function. One because opposing the weight will be lift.
Yes, it wasn't mentioned in the question, the lift part.
So let's take a snip. Okay. Have to stop sharing. Then is this visible? The
Yes,
aeroplane.
sir. Yes,
Now,
sir.
what are the forces that are going to act? There should be a lift which is perpendicular to the plane, and there should be a weight which is downward. So this would be your complete free body diagram, I think.
Yes, sir. I also think the lift should be there.
Lift
It
has
wasn't
to be there,
mentioned in the
otherwise it
question.
cannot be in equilibrium. What is opposing it from falling down? This is
Yes,
lift.
sir. That only I had found.
This is
Sir, theta can be
Sir,
90 degrees.
which theta.
The
How
angle
can
will be that is also possible because we have not been given any information in the question about Bayes or Bayes
but it
force.
is
T
not
and R
practical.
should be
Na?
collinear.
There will
For
be
theta
either
to be
it will be
90 degrees,
depending
this
on.
should not be an aeroplane, but this should be a rocket.
Yes, sir. So then T should be a function in both lift R and W, right?
Let the
Then what?
lift completely vertical in the upward direction.
Lift is perpendicular. So I think answer is LW cos theta.
so no answer is given there.
So we need to draw the free body only.
You only need to draw the free body diagram, and I have drawn the free body diagram as it should be.
Sir, should the
Okay,
lift
sir.
force be parallel to the
Thank you.
weight?
No.
Sir, I draw. So it's like the
Lift
normal
is
reaction.
perpendicular.
So like normal reaction in ground.
Yes. Perpendicular to the line joining the thrust and drag. Thrust and drag are normally collinear. Perpendicular to this is the lift.
Okay,
Sir,
sir.
but
Understood.
that
Fluid dynamic, fluid concept.
Hmm?
Sir, have you used the fluid Bernoulli one concept that the lower air would be of high speed, so it will apply pressure, so P into A will be the lift perpendicular to it. Sir, have you used that idea?
No, I have just used that. I know that lift. I did not think so much about it. I don't think just to draw a free body diagram, I would.
sir, but the drag, that lift thing, it should be opposite to the direction of velocity, no?
So it is perpendicular to thrust. That's what I'm saying. Now, thrust and drag are straight line. Perpendicular to thrust is lift.
So lift
Sir,
is given in question.
No, it is not given. You have to draw the free body diagram for, and I think the trick in this question was that you should know that just by thrust R and W, the body can never be in equilibrium. There has to be a fourth force. Just to identify that, that is the only trick.
Yes, sir.
Sir,
Okay.
Sir, I did
so
not
now
understand the
is acting
direction
on
of lift.
Yes, sir.
lift is basically perpendicular to thrust. It's a force which is perpendicular to thrust. In the context of this course, I think that is all you need to know.
Okay, sir.
Okay, sir.
Okay. Question number 3, 4, and 8 are similar. Let us look at question number 3. I will explain. What I want everybody to do is, once I finish explaining, please start solving question number 3. If you have finished question number 3, you should immediately go to question 4 and 8. And we will wait for some time to make sure that everybody has at least finished question number 3. If somebody is fast and he has done question 3, 4, and 8, good for him/her. But I want everybody to finish question 3 at least. Everybody should understand what's going on in this question. Okay. So in this question, you have a 100 kilogram wheel, which is this. This is resting on a rough surface, which is this, and bears against a frictionless roller A. A couple M is equal to applied, which is 60. Compute the reaction at A. So let us draw the free body diagram. I have put the free body diagram here. This boundary of the wheel is drawn. At the point, it is rough surface at the bottom. So I have put R1x, R2y, mass mg passing through the center, and normal A. Normal A is passing through this frictionless roller. And now we have to find f of A. Is this free body diagram clear? Everybody knows what to do next?
Sir, I have a doubt in that normal A, sir. Sir, what a roller does is it constrains the motion in one particular direction, so the normal should be a vertical or horizontal, no? At A.
No. Why? Remember, in one of the problems that we discussed in the video, there was a roller at an incline.
Yes, sir, but this plane is vertical where the roller is there.
But the contact between the big circle and the small circle is neither horizontal nor perpendicular. It has to be perpendicular to the contact. If the roller was at the bottom, you are right, there would be a normal reaction. But you have to look at the contact surface between the big circle and the small circle, draw a tangent there, normal to that is A.
Okay, sir. Understood, sir.
So please go ahead, solve it. We will wait for 5-8 minutes to make sure everybody answers this. In the meantime, if you have any questions specific to this question, now is a good time to ask. Yes, please. Any questions? Please try to answer this. I want everybody to at least finish this question before.
So the moment M is applied at a point away from C.
A couple M is applied. A couple M is independent of the location. Couple is not location specific.
So we can take it at C also, no?
Yes.
Okay, sir.
So if you look carefully at the free body diagram, there are 3 unknowns.
So what is the radius?
Radius is 300 millimeters given.
Oh, acha.
There are 3 unknowns, okay? R1x, R1y, A. And we want the value of A. So what equation of equilibrium is nice for us?
Sir, moment equation.
Moment about 0.1.
Sir, moment about 0.1. Yes.
Sir, moment
Please
about
do
that
this.
point.
Please solve this.
Point
Point
of
of contact with ground.
Moment about
Exactly.
and
So you should try to calculate the moment about this point, which I am highlighting. So about the point that I have put a circle, please try to calculate the moment about that point. You should get the answer.
I have a question.
Yes, tell me.
Sir, let us suppose that in this question we solved about C and we get two equations and we solve the problem. So that method is also is correct, or we should the shortest one is always considered as correct one.
In this course, we do not reward you for finding shortcuts. We are more interested in you being meticulous and accurate. So you might get hampered in terms of you might have less time for the other questions, but the longer one is wrong and the shorter one is right. There is no such concept.
Okay, sir.
So the moment that is given is about which point?
It's a couple. It's not a moment. Couples are not about any points. They are location in specific.
Okay.
Sir, sir,
Yes.
if we consider the moments about center,
You still have to take 60 Newton meter. You still have to take 60 Newton. Irrespective of where you take the moment about, this couple 60 Newton meter will have to come in your equation.
So then we will have just the applied moment and the moment because of the friction.
Yes, then you will, and if the frictional force was the unknown, then taking the moment about the center was a very good idea.
Sir. Sir.
Yes.
The answer is coming to 30.946.
I also got the same. Yes, sir, 230.946.
Yes, sir.
Yes,
But
sir.
in answer it given
Yes, sir,
231
exactly.
Newton.
ठीक है, okay. Like
Excuse me, sir, I have a doubt.
Yes.
Sir, if I'm getting confused by the couple, sir, then can I, just break it into two forces and applying some specific distance?
Normally, what you are doing should not cause an error. Yes.
Excuse me, sir.
Okay, sir.
Yes.
Sir, can we leave the final answer in fraction? Sir, I get FA as 400 by root 3. So can I leave this as 400 by root 3, or I have to divide the...
In Moodle, I think you cannot leave it like that. Had it been a pen and paper exam, had it been a pen and paper exam, if you do everything right, and the last step you leave it by 200 by 400 by square root of 3, then out of 10, you would be given 9.5. If it was a normal pen and paper exam, you would be in the campus, that would happen. In Moodle, you will have to write the final number. Okay.
Sir, I got 230.94.
Yeah, almost everybody is reporting that. That seems to be right. Okay, everybody understood this? I think there was some question about question number 8. So very quickly, I will just describe the problem and how the free body diagram is drawn. Then I think question 3, 4 and 8 are all similar. You should be able to do. Okay. Question 3 is clear to everybody?
Yes, sir.
Yes.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Good. So let us look at question number 8. I am projecting that slide. It should appear soon. Yes. Can you see that slide?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
So in this question, what is happening is you have two pipes which are heavy. They are tied by a thread. And in between the two pipes, you are holding some mass. If the mass is too high, A will have a tendency to go towards the left, B will have a tendency to go towards right, and this C would just fall down. We want to find out what is the value of C so that my entire setup remains in equilibrium. For that, we have to draw the diagram, free body diagram of A, and we have to draw the free body diagram of C. Okay, this is how the free body diagram of A would look like. There is a weight W, this tension T, the point of contact between A and C, there is a normal force RC. Point of contact between A and B is a normal force RB. RC and RB are passing through the center. Okay. This is how you draw the free body
Tension on
diagram.
A should be away.
Yes.
Tension on A should be away from that A, no? Arrow.
Tension at A
Yes, the
will also
tension
pass
direction
through.
should be.
Yes, the tension is always away from
Yes,
the
sir. Tension
Yes,
is away.
Yes,
otherwise it
sir.
should always pass from to the.
Thank you. Okay, so the free body diagram will look something like this. The trick in this question is only to find out the directions of the three forces. Once you are able to do this, I think you should be able to solve this problem.
Sir,
Yes.
sir, tension should also pass through the center, no?
Yes.
Yes, yes, yes.
Yes. Yes. Otherwise, it will not be in a state of equilibrium.
Yes, sir.
So this is the free body diagram of A. What will be the free body diagram of B look like?
Symmetric.
Mirror image.
Similar.
Same but
Sir,
Same in
exactly
opposite
like
direction.
it, the directions will be opposite. Mirror image type.
Sir,
Of
mirror
C.
image of A.
No, of C I am talking about.
two normal
So
forces
two-
and weight.
Two
Yeah, two
normal
normals
forces
and
from A and B.
Two
the weight
normal
out
at
of
one
weight
way.
Something like this.
Will these two normal be equal?
RC
Yes,
equal
yes.
and opposite is an internal reaction. So this is
And
also RC,
symmetric.
this is also RC. Both of them are RC. And this W. This will also be RC because entire thing is symmetric. Now can you solve the problem? At the point where equilibrium is lost, RB will be equal to 0. Because when the object C is about to fall, contact between A and B will be lost. RB will be equal to 0. And then you should be able to solve.
So it's coming 0.811, not times W.
How much is the
0.11
answer?
it's coming.
Could be. I think.
Yes, sir.
812 is
Exact
coming.
it is. Exact it is not matching, sir. Means it is not exact 0.8. There is some error.
Maybe they rounded it off to one place of decimal. So let us do. I think usually there is a problem for the students in finding the angle. So let me give you a hint. Okay, for the ones who could not find the angles. To find the angle, imagine this triangle. This is 3R, this length is 4, this length is 1, then you can find the angle for T. Similarly, you can find the angle for RC. Once you have this, I don't think this is a very complicated problem. Yes?
Can you please explain again that why RB is 0? I mean,
RB is 0 at, when equilibrium is lost, the small cylinder C will fall to the ground. And when the small cylinder C is about to fall to the ground, just before it is falling, the contact between A and B will be lost.
Sir?
okay, sir.
Yes.
Sir?
Yes.
So, can there be a condition that between A and B there is a gap, a little gap, and C stands right there? It doesn't drop to the ground. Can there be an equilibrium like that?
Can you repeat? I could not hear you. Please repeat your question.
So can there be an equilibrium like that when there is a little gap between A and B and C just holds right there, it doesn't drop to the ground?
Can the body be in equilibrium if A and B are not in contact? So for that one tiny phase, it will be yes. For some value of C, for some value of WC, that will be in equilibrium. That is the maximum value of WC that is possible.
But sir, as soon as A and B lose contact, C would have to fall on the ground. Like there can't be like C is still.
But for that tiny bit moment, it will be in static equilibrium. as soon as it increases even by an infinitely small amount delta, it will just fall.
Okay. Okay.
Very, at that stage, you will reach a very delicate balance between the three. Okay?
Okay, thank you.
Okay, so we have done question 3, question 8. I am assuming that at least 100% of the class has finished question 3 at least. And 50-60% of you must have finished question 3 and 8. 4 is based on the same principle, so I don't think we should do. Now we have question number 5, question number 9, and question number 10. All of them are based on the same principle, I think. So let us look at question number 9. What do you say?
Yes,
5,
sir.
9, and
Yes,
10,
sir.
all 5, 9, and 10
Yes,
all are
sir.
based on the concept of spring. And I think out of the 3, toughest is question 9. So let us do question 9. So all of you should try to solve question number 9 at least. If you have solved question 9, go to question 5 and 10. Read the statement carefully and try to understand, confirm if this free body diagram that I have drawn, whether you agree with this, and then tell me how we will solve this problem. A vertical load P is applied at the end of rod BC. This is P. The spring constant of the spring is K. When the spring is unextended, meaning that alpha theta is 0. When B and A are actually the same point, the spring is unextended. Now, when B and A are separated by some point, there is angle theta between ACB. The spring has increased by a little bit, so there is going to be some spring force. Now, we have to find out what is the relationship between theta, P, K, and L. So, first of all, let us look at how to draw the free body diagram. Pin joint at C, so I have RCX, RCY, load P, F spring. Yes, everybody I think by now agrees that this is the correct free body diagram. Yes or no?
Yes, sir.
Yes, sir.
Okay. Now the
Yes,
next
sir.
challenge in solving this problem is how do you find out the value of F spring?
Sir, I have doubt in free body diagram.
Yeah, tell me.
2L sin
See,
theta by 2.
the RCX, RCY should be in opposite direction.
Yesterday, also in my video, I told several times we will not care about the direction of reactions. When we solve it, if it is the opposite, we will get a negative magnitude. Free body diagram, irrespective of the right to left, left to right, free body diagram is correct. Yes?
Yes, sir.
So?
Okay, sir.
So now the open question in this problem is how do we find out the value of F spring? F spring is equal to what?
Cosine rule.
No, but we don't know
Sir.
the value of F spring. F
It
spring
will be
is because the spring has
2L sin theta by 2.
2KL sin
Initial
theta by
length
2.
of
Yeah,
the string and
yeah,
final
that's
length
from
of
there.
the string. We have to use
Let us
sine
go
law.
step by step. Initially, when the length of the spring plus inextensible string plus spring was AD, at that time my spring was unextended. Now it has become ADB. So the F spring is equal to K into AB.
Yes, sir.
Yes or no?
Yes, sir.
Yes,
Now,
sir.
Yes, sir.
okay. So with this hint, now please try to solve it. How will you calculate the length of AB? What will happen next? Try to do this. This is the hint that I can give you.
Cosine rule.
Cosine rule. Projection.
Look carefully.
We'll
AB
draw
is equal to BC. AB is AC is equal to BC. Using that, can you find out AB? It's
Yes.
It's an isosceles triangle.
property.
ABC is
2L
isosceles
sine
triangle.
theta by 2, sir. 2L sine theta by 2, sir. Actually, if you draw
Yes,
perpendicular
sir.
from C to this, then
Yes,
it
sir. I
will
use that
become.
only projection formula.
Same, yes.
Yes, sir.
2L sine
Irrespective,
theta
I
by
mean, there are
Yes,
many
sir. The
little.
same
12
thing,
sine
sir.
theta by
AB is what?
2L
What
sine
is
theta by 2.
correct? 2B.
2L sine theta by 2.
12 sine theta
Yes,
by
sir.
2.
That is right.
12
Yes,
sine
So
theta by 2.
AB is equal to 2L sine theta by 2. What is the value of F spring?
2K
2K sine theta by 2.
2KL sine theta by 2.
Okay, now solve this problem. And everybody should try to solve this problem. Okay, if somebody has solved this problem, no need to prompt the answer. Please, you can go to questions 5 and 10. After about, let us wait for 5, 8, 10 minutes. I want everybody to solve this before we go to the next. If
Sir,
you have
AB
solved it, if you have solved this,
AB
please go to question 5 and question 10.
Sir, AB and BC are not perpendicular to each other.
No, not necessary.
Sir, I had a doubt. Why is the extension AB? Shouldn't it be vertical extension? I mean,
No, it is spring. Na? The length of the spring plus string. When it was AD, then at that time it had no extension. And we are saying part of it is a spring plus inextensible spring. Spring plus inextensible spring. Initially, when it was AD, it was in an uncompressed state. Now it has become AD plus AB. So it means that the spring got extended by length AB.
yes, sir, got it.
Sir, I have a question.
Yeah, tell me.
Sir, is it necessary to draw the free body diagram of the body under consideration in every case? Can't we draw the entire system as a whole and consider it as a body and then take torque about moment about C?
Yes, you can do that.
Okay, sir.
If it was a pen and paper exam, it would be clearly written, draw the free body diagram, and there would be marks for the free body diagram.
Okay, sir.
But in this Moodle setup, yeah, we can't really check these things.
Excuse me, sir.
Yes.
Sir, can we take a small particle at the point where the load is applied and then draw FBD of that particle and apply tension in the rod, F spring and P, and then write equilibrium equation?
You are saying that member BC is a two-force member. So the free body diagram at point B will have P, FBC and F spring, correct?
Yes, sir. The tension in the rod.
It would be the same thing, yes.
That would also work, no?
Normally, if you get, I mean, the proof of the pudding is in the eating, as we say.
Okay, sir. I'll try doing that.
We are engineers. In Bhagavad Gita also it is written, Satya Sarthak hota hai. If it is truth, it will have to work.
Yes, sir.
Okay, anybody who does not understand this, I think, please, this is the time you have to be very clear about this. Make sure you understand this question completely. Use this time well.
The equations are not being able to be formed.
Take moment about point C. Moment
okay,
about
sir.
point C is 0. Because RCX, RCY are unknowns and we don't want that unknowns.
Sir, I have done using the concept that F spring P are passing through point B, then the third force, that is the reaction at C, should also pass through the same point, so that they should be concurrent. So then I use the sine law to determine.
That is fine.
Okay, sir.
Actually, BC is a two-force member. basically. If you look carefully, BC is a two-force member. So RCX, RCY has to pass through line BC. If you want to use
Yes, sir.
triangle law, that is also another hint I can give you.
Yes,
So
and
if we
it
take
is
so if we take RCX and RCY along the rod and perpendicular to the rod,
that's fine. That's fine. Yeah. Pin joint, you have two perpendicular reactions. It can be along any length.
okay.
FS
We
and
can
FP
use
are
If you
coming
sine.
along
worried
the
about
road.
C, I
So
think
they are
the
two force
equation you
member.
should get is P into L cos theta minus F spring into L cos theta by 2 is equal to 0.
Yes, sir.
Yes, sir, got it.
Sir, I
Then
got the
tan,
answer.
tan theta is Pk by L.
Sir, a rod is massless.
Yes.
Sir, what should we try next?
If question number 9 is done, please go to question 5 or question 10, whatever you like. Question 5, 9 and 10 are all based on the same or similar concepts. If you've understood this, you
so
should
the
normally
question
be able to do 5, 9 and 10.
10 I am having a bit of problem.
Okay, we'll see at the end.
Okay, sir.
Yes, sir, this is done.
Okay. We will wait for 3-4 more minutes. Okay, let everybody do it. If you have done it, go to question 5, go to question 10. It is 2:51. At around 2:55, I will go to the next type of question. Till then, whatever doubts you have on this question, you can ask. And if you have done, go to question 5, question 10.
So how do we calculate the angle between load P and the rod?
Load P, it is angle
And the rod
triangle
between.
ABC is isosceles triangle.
Yeah.
So
So I want to calculate the angle between the vertical and the rod.
which angle? Angle CAB?
Hmm. No. CBP. Angle between CBP.
CBP. Okay. So AC, use the fact that draw a parallel line to AC from B. Line parallel to AC passing through B. And then you should be able to do it. That will be perpendicular to P.
Okay. Yeah, got it.
Sir, do we need this thing that from B we will draw a perpendicular to AC and consider the angle as alpha, means A, B and some M to be alpha, and then from alpha we need to drive. Do we need this?
I don't think so. As I said, I just took moment about point C. And my equations were very simple. It is P into L cos theta minus F spring into L cos theta by 2 is equal to 0. That's it. Very straightforward.
Yes.
Sir, can you please repeat what you just said?
So take moment about point C, equate it to 0 for equilibrium. Moment about C, summation NC is equal to 0, counterclockwise positive. You should get the equation P into L cos theta minus F spring into L cos theta by 2 is equal to 0. Where F spring is equal to 2KL sin theta by 2. Put that and then normally you should get it. So P into L cos theta minus F spring into L cos theta by 2 is equal to 0.
Sir, then theta will be equals to sine inverse, na? Sine inverse P by KL.
No. So you are getting
Hmm.
PL cos
No, no,
theta
no.
minus 2KL square sin theta by 2 cos theta by 2. 2 sin theta by 2 cos theta by 2 is equal to actually sin theta. P cos theta is equal to KL sin theta. Tan theta is P by KL. Okay?
Okay, sir.
Sir, I have a doubt in question 5.
5.
Sir, actually my answer is numerical answer is correct, but direction is coming different.
Okay, we'll come to it after we finish at least one problem of each type. Okay?
Okay, sir.
Okay? So is this, I mean, the concept of spring clear? Yes. If there are problems like spring, is it okay?
Yes, sir.
Shaurya,
Yes. Yes,
how
sir.
did we find? Shaurya is
Yes,
asking,
sir.
how did we find string force? We found out string force by noting that AB is the extension of the spring by its basic trigonometry. Okay, now look at, so question 5, 9 and 10 are essentially similar, and I am assuming that majority of you have at least done question number 9 that we just discussed. Now, question number 6 and 7 are similar. Let us do question number 6. Okay, so let me briefly explain what this problem is saying. According to this problem, you have a bar ACE. It is held by two threads, one at B, one at D. Okay, now A is known and also P is known to be 5 kilonewton. We have to find out what is the range of Q so that my entire structure is in a state of equilibrium. Because I know that if in the string the load is greater than 12 kilonewton, then my string is going to break. Okay, either B will break or D will break as soon as tension in thread at B or tension at thread at D is greater than equal to 12 kilonewton. We have to find out the range of Q such that the tension at B and tension at D does not increase 12 kilonewton. Now you might say, what happens if Q is 0? That is the minimum value, right? But you will see that if Q is equal to 0, it might fail, but if Q is equal to 1.5, it will not fail. That is, I mean, to drive home this point, this is the whole point of this question. We have to find out what is the value of Q. P is 5, A is 7.5, such that BD is less than equal to 12, D is also less than equal to 12. So first of all, let us draw the free body diagram, which is very straightforward for this. There is a bar. Then I need to just look at is this correct free body diagram? Yes or no? Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay, so now look at this and tell me, for this free body diagram, how many equations of equilibrium can you get?
Sir, 2.
2.
Why not 3? Will you explain to the class?
Sir, in the x-axis, the forces are already 0. So
Already 0. So you only have 2 equations. Okay. Now you have what is known. We know that this is 7.5 kilonewton. This is known. This is known. This is unknown. This is unknown. This is unknown. Okay.
Sir, can we say that for minimum value of Q, string B will have maximum tension, and for maximum value of Q, string D will have maximum tension?
That is right. So,
Yes,
find
sir.
out
By
the minimum
considering
value of
moments about B and D, we can do this.
So if for minimum value of Q, this should be equal to 12 kilonewton. When this happens, Q has minimum value. And when this is 12 kilonewton, Q has the maximum allowed value. That way, you have to solve this thing twice. Okay? Understood? When Q is minimum, the load at B will be maximum, and that is limited to 12. So we can write at B 12 kilonewton. Then you can find out the minimum value of Q. And when Q is maximum possible, then the load at D is 12 kilonewton. You can find out the maximum value of Q.
Sir, I didn't really get this. How is it?
Sir, I also can get. Can you explain once more?
Yes. So we are saying that the string at B and the string at D can break if the load is more than 12 kilonewton. Okay. Now, first of all, try to solve this assuming that Q is 0. Let us say, argument's sake, what happens if Q is 0? Can you find out the value of TB for this? Anybody, what is the value of TB when Q is equal to 0?
$16.5.
It is greater than 12. It is some number greater than 12. Okay. 16.5 probably is right. So it means that if Q is 0, my string at B is going to break. So Q will have to be some positive number, otherwise my string is anyways breaking. So it has to be greater than 0. So let this be 12. Let this be X. Find the value of X.
Sir, I got the answer, but how only considering the maximum value of tension at T1 guarantee Q is minimum and not the other way around means
Find both. You will get the range. After
Hi,
that,
sir. Yes, sir.
assume this to be 12. Assume this to be question. Find the value of X.
Means without solving the equations, we cannot qualitatively say that considering.
Correct. You are right. Yes.
Okay, sir.
By individually putting the value of TB and TB to be 12, you can find out the two limits of X or the two limits of Q. You can then
Yes,
find out
after finding we can quote. After finding we can quote.
Yes.
Okay, sir.
This example is also an example where in certain engineering applications, applying some load is actually helping my system. Applying the load Q is equal to 1.5 is better than making sure that the load at Q is 0. If the load at Q is equal to 0, my entire structure would fail. But by applying some load at Q, I am counterbalancing the net moment and my structure is actually safer.
Sir, so for coming to this conclusion, first we solve the inequalities and then we get to know what is happening. We cannot directly, means by seeing the system, conclude this.
Normally you can say, but it will require some intuition. For you at this stage of your career, it's okay that you want to do it and then you want to be doubly sure.
Okay, sir.
Okay, so this also tells you that how difficult it is to design structures. Yes, intuitively you will think that if I apply less load, but the better it is for my structure. But this is an example where this is not true. So making a structure is difficult. What Tanmay is saying is also right. You can find Q in terms of TB and TD, and then you write an inequality equation. That is also fine. Okay. Please try to solve this. Everybody try to solve
sir.
this. If you have already solved this, go to question number 7.
Excuse me, sir. In this, I had a doubt that
Yes.
when we are taking 12, so how can we be assured that taking 12 will give us either maximum or minimum? Means
Because it
it
is
can
said,
be like
because
this.
it is said that, no, no, because in the question it is said that that is the strength of the strings. That's why, that is the reason for the number 12.
So, but it can be like this, na, ki if the both the strings are having tension like 11.5, 11.5, and for that value Q is coming maximum, can't it happen?
For that, try to use the approach which Tanmay has used. Try to find Q in terms of TB and TD and then apply inequality equations. Try to solve it like that.
Yes, sir.
So if Q is 0, then why won't the string at D balance the rest of the forces?
Then it's not in a state of equilibrium. The tension in the string is more than 12.
I'm saying that some tension in string B would be less than 12 and tension in D would be like 5 or 6 kilonewton.
Yes. So then we want both that string at B and D not to fail.
Okay.
So can you explain it again, because I lost my connection, internet connection.
So in this problem, basically we have to make sure that TB and TD, both of them are below 12. Okay. The first thing let us try to do is put the value of Q is equal to 0. If you put Q is equal to 0, you will see that TB is more than 12. So it means that we have to apply some value of Q so that both of them are below 12. So in the first step, assume that TB is unknown, TD is 12. Find the value of Q for equilibrium.
Sir, what is a truss?
What is a
Truss? It's in the question 7. It's written. Consider the truss.
truss is a structure
It's the
made of
same doubt.
all of them are two force members. Truss is in an engineering term, when you go through a bridge over a river, you have the structure on both the sides of the road.
Yes, yes.
That is a truss.
Okay. But how are all of them two? Okay, okay, I understand now. Okay, yes.
So I have a question which is actually related to 7, but not strictly related to the problem itself.
Tell me.
So are the actual trusses in real life also designed keeping in view of these maximum and maximum stress that they can handle, like the bridges and all?
Yes, when you design a truss, when you design a bridge, you have to think about several things. One is the reaction of the supports. Your support should not collapse. But most critical usually are the pins which are joining the different members. They are most likely to fail. So you have to make sure that those are thick enough.
Okay, sir. Thank you.
We will discuss this in great detail in the month of January when we have concept of stress. I will be making the videos for that topic also.
Okay, sir.
I will wait for 5 more minutes. Everybody should be able to try to finish this
Sir, I have
problem.
done 7. Is there anything else I can do with this?
If you have finished 6, then you should go to 7. If you have done 6 and 7, then please wait for the rest of us. In 5 minutes, we will join you.
Sure, sir.
Sir?
Yes.
So actually I have doubt in 11 and 12, sir. Actually I have solved all this problem.
Those are
But
next type of
last
problems.
two,
We have 1 hour left.
Okay,
So we
sir.
have 1 hour basically for question 11 and 12.
Thank you, sir.
Sir, I could not quite understand the
Yes.
configuration of question number 7.
Question 7. Okay.
Sir,
The diagram I could not understand properly.
Okay.
Yes, sir.
Yes, sir. It's a problem with me too, sir. Please explain the question 7.
Okay.
Sir, especially I'm confused with the roller configuration.
Okay.
Sir, my answer is coming 353.5 Newton, but the given answer is 354.
Could be. Very likely that you are right.
Okay.
So let me zoom to this part where you have problems. Yes, what is the question? I have zoomed the part where you are saying you have doubts. Is the doubt what is the direction of the reaction force? Is that the problem?
Yes, sir.
It will be in this direction. In this direction, perpendicular to this line, and it is at 45 degrees. So this is roller at an incline. Okay?
Yes, sir. Okay.
If you have doubts on this, please go to my presentation number 3, example number 5. In the third presentation, 5th example is based on this idea.
So what is the truss here?
Truss is actually, this entire structure is known as a truss. This, these triangles. In real life, if you have a bridge over a river, usually on both sides of the road, you see a structure like this. Or if you see an advertisement hoarding from the back, you will see lots of triangles like this, where a structure is made by joining triangles. These structures are known as truss. They are very important in civil engineering and aerospace applications. The first part of problem sheet number 4 is dedicated exclusively to truss.
So the triangles you have to consider in truss are only the upright ones, no?
You only need to, for this problem, you can neglect the inner detail, just draw the free body diagram of the outer boundaries. What is happening inside individual member is, at least for this, none of your concern. My point is, this truss is just distracting you, even if this problem. So let me redraw another figure. Okay, 1 minute.
We can only consider the outline also.
Yes, that's what I'm saying. Exactly. So if
Yes, so
instead of
considering all the members.
If instead of truss, if it was written, consider the trapezium, then also this problem is exactly the same.
Yes, sir.
Basically, you have 3 known forces, F, pin joint at A, AX, AY, roller at B, normal at a certain angle, take moment about point A, get the answer. Okay.
So
And Has everybody finished this problem?
Yes, sir.
Yes, sir.
Sir,
Yes, sir.
in question 6, in what case both the string will be at their maximum tension?
Question
6, sir.
I don't think at any case it is both of them are going to be equal. TB and
Okay.
TD will be different most of the cases. You can you can try to solve this. I mean, if you are interested, you can also try to solve the problem. Find the value of Q such that TB and TD are equal.
Okay.
Find the value of Q such that the value of TB and TD is minimum.
Okay, sir.
Find the value of Q so that TB and TD is maximum, then Q is equal to infinity. That is simple. But when it is minimum and when it is equal, I think more parts of this question can be attempted. Looks
Sir,
like
I am
Tanmay has
also
already
getting
solved this problem. Tanmay,
353.55 Newton.
which one?
So this bridge one, 353.55 Newton.
Something like that. I think all the
Yes, sir. Same answer.
numbers in the problem sheet have been rounded off.
500 by root.
Okay. Now, the next type of problem is question number 11. Question number 11 and 12 are both unique and we will have to spend time in that. This is question number 11. So, in this, what is happening is there is a cylinder like this gray color cylinder you are having. This you are trying to rotate by holding at the two ends and then you are trying to rotate it like this. To rotate it, you have to apply a moment of 800 Newton meter. This diameter is 200. If you are able to somehow cause a moment of 800 Newton meter, then this gray object will start to rotate. You have to find out what is the load P you have to apply to get the necessary rotation.
Moment is 80, right?
Moment is 80 Newton meter.
Yes, sir.
So for that, 8080. For that, you have to draw the free body diagram of the.
Sir.
Yes.
So this moment is due to only P or it is other?
So only due to P. Due to P, there is reaction at RA, reaction at RB, and a moment.
So it is telling in question that for rotation of the diameter of 200 diameter. So it is not the question of statics, sir. It is the problem of dynamic, I
No,
think.
just before it starts to rotate, if a moment is 79.99999, it is in a state of equilibrium. If it is 80.0001, it is starting to rotate.
Okay, sir, got it, sir. I thought
But
that
it is
it
pinned
will
that
rotate.
it have permission.
Yes.
The range is pinned at B. So wouldn't that cause obstruct the rotation?
What is pinned at B? Engagement is just a normal. It is just somehow you are clamping it.
Yes, sir.
Sir, can you explain the question once again?
Yes.
So the whole part is not in contact.
So let me do something. I will on my camera and try to show you with my hands what is actually happening. Okay, please 1 minute. Stay on the line. I have to go to my laptop.
Sir, you are not audible.
Yeah,
Sir, you are not audible.
Hello?
Yes, sir.
Yes,
Yes,
sir, you're
sir.
audible.
Yes, sir.
Yes, sir.
One
You are
minute, I have
audible.
to mute my other computer. Oh, good. So now imagine that this is the circular cylinder that we are trying to hold, okay? And this arm is the hook wrench. Can you see me?
Yes, sir.
Yes, sir. Yes, sir.
No, sir.
With
Yes,
this,
No,
with my
sir.
two fingers, I am holding
No,
it
sir.
tightly.
No,
Yes, sir.
Sir,
I
you
am
are
holding
not
it tightly.
visible.
No,
Look
sir.
carefully.
You are not visible.
Sir, you
Pin,
are not
search,
visible.
pin. Search and pin.
You are
Search.
visible, sir. You are
Search and
visible.
pin, search
Pin,
video.
pin,
No,
search,
normally I
pin.
should be visible.
Yes,
I
I
sir.
can
have
see
pin.
myself.
Sir,
All guys have
we
Yes,
have
sir.
to
Now
Yes,
you
play
are
one
sir.
more
visible.
You are
video.
pin, sir, pin.
Now you are visible.
You pinned.
So this is the cylinder, okay? My arm is the hook. So with my fingers, I am holding it tightly and applying load here so that it rotates. Clear? Hold it tightly like this with two fingers. Apply load through my elbow. It is going to come up. Correct?
Yes, sir.
Yes,
Yes,
sir.
That's
sir.
what we're trying to do.
Yes, sir. Yes, sir.
Yes, sir.
One minute.
Sir,
So hold it with two fingers. If you hold something with two fingers, what is the reaction that you are putting on the circle? Normal to the circle, correct?
Yes, no, only normally.
Yes,
Yes,
sir.
sir.
Yes,
Only
sir.
So
Yes,
that is
Only
RA
normal.
and RB.
yes, sir.
Yes.
Yes,
Now,
sir.
if
Yes,
I
sir.
apply a load
Right,
P
sir.
at my elbow, this entire thing will have a tendency to rotate.
Yes, sir.
Yes, sir.
That is 80 Newton meter. You have to
Yes,
find out
sir.
what is the load P that I am applying at my elbow.
Sir, that means the cylinder is not slipping.
The cylinder is not slipping. To avoid slippages, usually you will either make the surface slightly rough or you make a very small hole, which is shown here. If you look carefully
Okay.
below E, that detail is given so that it does not slip.
Okay, sir. Understood.
Sir, so the
sir,
cylinder is
but
going
in
above the
Rotates.
horizontal line, no? To rotate,
Sir,
or
where is the hole given?
Where is the?
Hole given you're talking about?
At B, at point B,
That
there's
is
a hole.
P. That is the load P that you are applying.
Okay, sir.
sir, so is it rotating about O or P?
It is rotating about O.
Okay, sir.
sir,
You see
but
this?
in wrench, the
You see
whole
this one,
wrench.
na? It is rotating like this. My arm is actually bending at my wrist with this hook. That would not happen. It would hold like this and the entire thing would rotate about O. Yes or no? Understood?
Yes, sir.
Yes, sir.
Sir, your
Yes, sir.
complete hand
Okay,
must
Yes,
be
sir.
in contact,
Now try
not
to solve
two
this.
fingers.
Sir,
Sir, is the
Yes.
hook wrench massless?
Is what?
Hook wrench, this wrench one massless?
Yes.
sir, I have a doubt in the. We have not considered the circular body in FBD, which is held between the
Circular
the
body
two.
is in the circular body is in a state of equilibrium if the moment is 79.99999. It will start moving if it becomes 80.00001.
Sir,
And
but
we
I
are
have a
trying
doubt
to solve the problem when moment is 80.
that if we consider the FBD of circular body, then who is providing moment to that body? How will it
The
rotate?
reactions.
Because there is no friction. The reaction will pass through the center of body.
There-
So who will rotate that circle?
Yes, sir. Same doubt.
The
There
same
should
doubt.
be some friction.
But that is
Same
due to the
also
mass.
present at
Sorry,
least.
that is due to the mass that we are ignoring. There is a third force, the mass of the shaft. If it is massless, then it would be rotating by itself.
I did not understand this thing, sir. Can you please explain?
So this circular
So actually it
object
is
could
happening
be
due to
part of
the
a bigger
hole at
structure.
B.
No, wait. This circular object could be part of a bigger structure. It could be something like this, right? That this is my circular object. It is holding at one end and then I'm trying to rotate it.
Yes.
This
Okay,
is
so
the circular
center
object.
of mass is not necessarily the center of circle. Okay.
You hold it or the mass is not at the center. Anything can happen.
Okay, sir.
Okay, please try to solve this.
Sir, but weight will also pass through the center of circle.
Which one?
Weight.
Nothing is said about the circular object. I think either the circular object center of gravity is not the center, or it is constant by something else which is outside this question. One of the two things has to
I am
happen.
not
Otherwise,
getting
my
the
circular
answer.
object will not be in equilibrium.
Okay, sir.
So I'm also not getting the answer.
So we have to calculate moment about O of P.
Ayub, take moment about O and get the answer.
Sir, but answer is not coming.
Sir.
Yes, sir.
1 minute. I
Sir,
am going
won't
back to my
any
computer because
tangential
the
force-
presentation is there. Please
Sir,
hold
can
on
you
for 1
explain
minute.
it once again?
I am getting R equal to 123.16.
Yes, same.
Yes, I am back.
Same 123.16.
123.1. Yes, I got same.
I am getting 10. Basically, take moment
Yes, sir.
about
123.168.
what is the is the take moment about point O. 1 minute, echo. Yes. Now take moment about point O. Are you getting M0 is equal to P into 375 divided by 1000?
Yes, sir.
So what is
Yes,
the
sir.
value? What is the value of P that you are getting?
213.33 Newton.
13.33.
That is right. Now let us take moment about point B. We need the value of RA. Next step, take the moment about B. What equation are you using? RA into 100 into sine 120. Yes.
Yes.
Sir, I had one doubt.
Minus, wait. What is the moment of equation? Right. Take the moment about point B, equate it to 0. What is the equation that you are getting?
P into 375 by 1000.
P into 425 by 1000.
P into 100 cos 60 plus 375.
Cos 60.
So directly we can use sine rule.
375 plus P 100 sine 30.
I'm saying cos, say that the same thing. I'm saying cos 60, you are saying sine 30. Is equal to RA into 100 into sine 120. If you equate it, normally RA is equal to 1046, I am getting. So essentially 86.6 RA is equal to 425 P. Are you getting this?
No, sir.
No, sir.
No, sir.
No, sir.
Eh?
Sir, I think you interchange sine and cos.
I am writing RA. Please correct, okay? I am spelling out my equation. Please correct if it is right or wrong. RA into 100 into sine 120 minus 100 into cos 60 plus 375 into P is equal to 0.
Sir, we'll equate to 80, no?
Why?
80 is for the sphere. For the
80 is in the
cylinder.
sphere, na? When you draw the
80 is
cuboid
given
diagram.
in question.
80 is
Sir, I
already
got
used.
1047.
Yes, sir.
80
It is
Sir, I got
104.7.
104.7.
External reaction. When you are drawing the free body diagram of only the hook wrench, that 80 is not coming into the picture. When you draw the free body diagram of the entire structure, that 80 is coming into the picture.
Sir, just a question. Can we, on the hook wrench, can we apply force balance?
You can do that also, yes.
So, but force
Sir,
balance,
force
I'm
balance,
getting
different answer.
different answer.
Different
answer
force
is
balance,
coming.
different answer is coming. 123.17.
Yes, sir, exactly.
Yes, sir.
Yes, sir. I
As
use
it is,
sine or same thing.
the correct answer, I think, what exactly I have
Sir,
got
I
is
think, sir, I think one.
104.323.
Excuse me, sir.
Yes.
I think one force is missing in the FBD on the PPT.
Which force?
At B, I think there should be one tangential force also.
But we are taking moment about point B, so why should it matter? Even if
No,
argument
they want to do force balance. That's why we cannot ignore that force. I think that's why they're not getting the answer with force balance.
Why should there be a tangential force?
Because at B there is a groove and the pin is inserted into the groove, so there should be a tangential normal reaction.
But it is saying
Normal force inside the groove.
Yes,
the
the
engagement of the
tangential
force
normal.
may be considered to occur at the periphery of the collar.
Yes, that is to that is in order to keep the force at the periphery. This is a very small groove, but it will apply a tangential normal to the pin at B.
Sir, the cylinder can't slip at B, so sir, there can be a tangential force, sir. Sir, because the cylinder can't slip at B.
Moreover, if there is no tangential force at B, then the cylinder cannot rotate because there is no direct movement on the cylinder.
Yes, sir. Then it would
All the
slip,
forces
sir.
pass through the center.
Center, exactly.
Must be there then.
So to do
Sir,
force
like
balance, we need to
friction,
consider
like
that force.
friction, we must have a tangential force here.
Something like this, you mean?
That is not friction, it's normal force due to the groove.
Yes, yeah,
Yes,
yeah,
but
yeah.
like friction, I am telling.
So yes, like friction. Yes.
Could be.
Sir,
Yeah, what
because
you are
pin
saying-
joint always exerts force in two directions, not only one. It is pin
Yeah,
joint.
because I think what you are saying is, since we are making a hole, so then there will be, if we look at again from the, if we try to imagine this small slot, if it wants to move down, it cannot move. If it wants to move side also, it cannot move, right?
Yes, sir.
Yes, sir. Yes.
You are, yes. So there should have been a
Two
reaction.
forces.
Yes,
So
sir.
there will be three forces and three equations: X equilibrium, Y equilibrium, and moment equilibrium.
And then you'll get the answer. Correct.
Yes, sir.
Otherwise, you just take moment about B and equate it to RA.
Yes.
What
Sir.
I have done.
Sir, I'm getting 1046.92.
I'm
Yes,
getting
that's
1045.959.
Yes, I also got some kind of that answer.
I think it is
Means the
because of
answer
the
divided by 100.
I think it is all because of rounding off of the, the equation has sine 120 and cos 30. That is the source of some ambiguity.
Okay.
Equation I think should be RA into 100 sine 120 minus, in a bracket, 100 cos 60 plus 375 close bracket into P is equal to 0.
Yes, sir.
Yes. Yes, sir.
Okay, good.
Sir,
you.
could you
Rajesh.
just explain once again in brief?
Yes.
Sir, could you just explain once again in brief? I have lost the track.
Of what? Of this problem?
Yes, sir.
So basically, first of all, draw the free body diagram of the entire structure. P is causing a moment. You will get the value of P in terms of moment, which is given to be 80. Step 1. Now draw the free body diagram of this hook wrench only. We want to find out the value of RB. There are three unknowns: RA, RB, and this tangential force. RA is the unknown that we want to calculate. So take moment about point P, get the value of RA.
Okay, sir.
Okay?
Sir, I have a doubt. Hello?
Yes.
Sir, you're not audible.
Tell me.
Yes, sir. Just now you said that at pin B, there will be a tangential reaction as well as a normal reaction. So if we consider the circular body and take the moment about the center of the circular body to be 80, will in the direction.
No, wait. The 80 normal is going to be important if you take the free body diagram of the entire structure. If you draw the free body diagram of the hook wrench only, then that 80 is not coming into the picture. 80 is the moment in the shaft. is the external. When you're looking
Sir,
at the
then
structure
how?
as a whole.
Sir, then how will, if
Why
we had a
can't we
question
do
of
force
calculating
balance?
the tangential force, if we had a question that calculate the tangential force, then
At
at point B, then how will we
okay,
do that? How will we do that?
you would find I would do it like that. I would take moment about B, find the value of RA. I already know P. Summation Fx is 0, Fy is 0. Get the two reactions at B.
Okay, okay, sir.
Why can't we do force balance?
You can do force balance. There are 3 unknowns. Write 3 equations, whichever way you like. It's all perfectly fine.
We should consider tangential force at B.
Yeah, for that, then you have to take also into care the tangential force.
Okay. Hello, sir.
Yes.
Sir, there can't be tangential force at A, like at B.
No,
A
but
is smooth.
A is smooth, no? It is written, I think.
A is not hooked.
Oh, smooth surface at A.
Sir, by doing force balance, there would be 4 variables. One, the tangential force at B, and the 2 normal forces, and the P itself.
P is known. P is known.
Okay,
We will get the
okay,
value
sir.
of P.
Okay, I got it.
Sir,
Yes.
sir, can you please explain why there will be tangential force at B?
Because if you look carefully, there is a pin which is going inside the structure.
Yes, sir.
Try to imagine the free body diagram of this pin. Can this pin move in this direction? Can the pin go up and down like this? No, because this circle will not allow. Yes?
Yes, sir.
Similarly, can my pin travel in this direction? It won't allow because the wall of this shaft will not allow that. Yes?
Yes, sir.
That's why you have tangential and normal.
Okay, sir. Thank you.
So now we have to write tangential force in moment equation.
So I would actually, that's why there are 2 unknowns passing through B, and we want the value of the third unknown. So it's very convenient to take summation MB is equal to 0.
Sir, if I'm taking about O, then what is my moment equation?
If you take about O, RA, RB are passing through O, so it will become P into 375 minus tangential force into 100 is equal to 0.
Okay, sir. Okay, sir.
Sir, I have a doubt that when we draw the free body diagram of the wrench, we consider it to be in equilibrium.
Yes.
Why is that so?
Huh?
Why if the system is rotating, then the wrench
system is
should
not
also.
rotating. System will start rotating if the moment is 80.001, and we are saying it is
Okay,
80.
just in a state of rest. Okay.
Yes, yes.
Sir, RA and
Sir.
RB must be in opposite direction, no? Why is it in outward direction?
You tell me. What
Sir,
will happen if I... Yes, yes.
The thing will push the cylinder inside, no?
Is the sign of the reactions important?
No, sir, but while taking the moments from B, it would be important, no?
No, it would not be important.
Okay,
I would get
it
the
will come
value
out to
of
be
R
negative.
minus if I am doing it wrong.
Okay.
See,
Yes.
for finding tangential force, can we draw? We will draw the free body diagram of the collar, and then the torque will be provided by the tangential force, and if we can equate it to the net torque required, that is Will the answer be right?
Can you repeat your question, please?
If we draw free body diagram of the color
of the wrench, of the hook wrench.
Yes. So
And
the sphere
of the cylinder, yes, and then
we have a tangential force, right? It will give a torque. It will give a moment to it. So can we equate that moment with 80 Newton meter?
no, but that is an internal reaction. You are not drawing a free body diagram of the cylinder. You are actually drawing a free body diagram of the entire structure in the first step to get the value of P.
Saying that I am drawing the free body diagram.
So to get the value of P, when we use the fact that M is equal to 80 Newton meter, the internal reactions in B and A are not important.
Okay, sir.
Sir,
Yes.
sir, can you tell once more what all equations in total we have to use? Means we have to use the torque equation at point O and then at point B also.
So take the moment about O, you will get the relationship between P and 80 Newton meter. This time you are looking at the entire structure, not just the shaft or not just the hook wrench. Imagine the free body diagram of the entire structure. There is a load P and there is a moment of 80 Newton meter.
Yes, sir, after that we will
After
get a
that,
relation.
that gives you the value of P.
Okay, sir.
Now
Yes,
draw the
after
free
that.
body diagram of the hook wrench. When you draw the free body diagram of the hook wrench, the internal reactions RA and RB will come into the picture. But the moment 80 Newton meter is no longer a part of the hook wrench. It was a part of the overall structure. So let us look at the hook wrench. You have internal reactions at A and B. The internal reaction at A is the unknown. So take moment about point B is equal to 0. You will get a relationship between RA and P.
Yes, sir, understood. Thank you, sir.
Okay.
Yes, sir.
Let us go
Yes,
now
sir.
to the last problem, which I think is also the toughest. Could anybody solve question number 12?
Sir, I think the question should be, could anyone understand question 12?
Anybody?
Yes,
Okay, I will change
Sir,
my
let
question.
me read it once. I did not attempt that question.
Okay.
Same, sir.
I have solved
I
this
did not
question.
understand the
I
question
will not
language.
attempt.
What is feeling about that?
How many of you have actually
Sir.
managed to solve?
Sir, I have solved. Sir, since
Good.
we have time, can you give us 5 minutes time?
No, I can explain. I'm just curious only. We have enough time. I'm just curious how many of you could do it. It doesn't matter if you could not do it. We will
Sir,
still
I have
discuss it.
solved.
Yes, sir. I didn't try.
Sir, I can try.
Sir, I have solved.
Let us try. Let us try it all together. Okay. This is a special
Sir,
sort
wait,
of a.
sir.
I'm explaining. I'm just explaining. Don't worry. I'm not solving the problem.
Sir. Since you are saying that it's the toughest question, can you please let us do it by ourselves for 2 minutes?
Yes, sir.
Okay, so it is 3:43. I'm giving you time till 3:50. After 3:50, I will start to explain. Okay, because at
Okay,
4
sir.
o'clock we have
Okay,
to
sir.
wind it up. It is
Sure, sir.
3:40.
Okay, sir.
6 minutes for you to solve.
Okay, sir.
At least to understand, not to solve, but to understand what is going on.
देव 1000 में बहुत होते हैं, मम्मी मैं देखा था 1000 खर्च नहीं हुए थे।
Excuse me, sir. What does this 80 mg sector mean? Is it the weight?
Yes.
Mg is milligrams or something.
1 minute. What does this? What in the question? I think mass is 80. So 80 into mg. I mean, you write now mass is mg. Mass into constant
Okay,
g. So here they're writing 80 mass into g.
I think it will be 80 kg, sir. 80 kg.
Let me see.
Maybe some mega kg.
No, it is.
I mean 10 to the power 3 kg.
80 into W is, I have taken 80 into 10 to the power 3 into 9.8. W is equal to mg is equal to 80 into 10 to the power 3 into 9.8. Is it 80 into 10 to the power 6 grams? Is it? M stands for 10 to
80
the power 6.
megagrams.
Yes, yes, yes. So
M
take
is
W is
capital, so I
equal to
think
80 into 10 to the power 3 into 9.8. That is the mass, W. The force due to its own mass is 80 into 10 to the power 3 into 9.8.
Sir, in our exams, all the problems will be of this level.
No. Short answer, no.
Sir, I understood the problem, but I have to think how to solve this.
80, that is megagram or milligram or mg.
So
What is
W, the force due to its own weight is 80 into 10 to the power 3 into 9.8.
Okay, sir.
I mean, I don't want to scare you, but I can tell you that throughout the course, this I think is the easiest problem sheet. So for the students who usually struggle to get a P are the ones who don't get anything out of problem sheets 2 and 4. 2 and 4 are going to be the easiest. The students, I mean, in general, yes, there are all types of students. There are some students or most students who would like to get an EX. They have to master all the topics. On the other side, sometimes there are students who are thinking that how should I pass? That is my first objective. For those students, problem sheet number 2 and problem sheet number 4 are going to be critical. That is probably the most easiest scoring topics in the entire topic. And the problem sheets, usually you will see the difficulty level, I think, would be somewhere between 6 and 10, and in the exam you can expect difficulty level 6 to 8. Perhaps I think something like that you can expect. So if this problem in question, in the problem question number 12 has difficulty,
You are not audible.
Sir, your voice is not coming.
in the course as you go. Hello, can you hear me?
Yes, sir.
Hello.
Can you
Yeah.
repeat?
My point is,
Yes,
I
sir, you're
think
audible.
things will get harder and harder. Hello? Am I audible?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. So my point
Yes,
is,
sir.
things will get tougher and tougher. The two easy problem sheets are 2 and 4. After that, it progressively gets harder, especially when we go to stress and strain. Those are new concepts and they get harder and harder. So, I mean, if you're on the other end of the spectrum where you are not thinking about EX, but you are thinking about how should I guarantee myself a P, then you should master problem sheet number 2 and 4. That is your passport to getting a P. At least 2 and 4 you have to get. Okay, I think let me try to explain what is happening in this problem because we don't have enough time. Okay, so here you have a certain mass and at B you have a gear. So
done.
what does a gear do? Hello?
Yes, sir.
Hello?
Done. Yes, sir.
Yes,
Yes, sir, you're
Sir,
audible.
audible.
yes, sir. You
Sir,
are
Yeah.
audible.
is it small pulley?
Huh?
Gear
Somebody
means
saying
it is small pulley.
it is what?
Sir, it
Pulley.
ensures a rotation.
We can apply external torque at B.
Yes.
So basically what this gear does is you apply a torque at the gear and in return you get some normal and tangential force which will cause the entire structure to move in a clockwise or in a counterclockwise manner. So a gear is a device where you can transfer rotation from one body to the other. So the free body diagram of the gear at B looks something like this. You have a normal and tangential force at the point of contact between the jig and the gear, which I have drawn RB and F. Moment M is applied and there is a normal force where the gear is resting. This is the free body diagram of the gear. Now, what you have to do is you have to calculate the value of F for a certain amount of torque. If the torque applied is 2460 Newton meter, what is the value of F? If the torque applied is 4680 Newton meter, what is the F? That is the first step. This is what a gear does. Now let us look at the 1 minute. I think slide should appear soon. Yes. Now let us look at the free body diagram of the rig or the jig. When alpha is 0, you have reaction RA, force F, reactions RB, mass mg. Mass mg is passing through some point in the rig and its precise location can be defined as a function of r and theta, let us say. Okay. In this condition, F is pointing from right to left. When alpha is 30 degree, you have RA, you have RB, F, and the same weight mg is passing through some point whose coordinates is r theta in the cylindrical coordinate axis system. The direction of the F you can get from your previous step when you relate M with F. Take moment about the center. RB and R will pass through the center. F will come out to be a function of M. Now, once you draw the free body diagram for what happens when alpha is theta, when alpha is 0, take moment about point O. RA is passing through O, RB is passing through O. So you will get some relationship between F, which is 2460, which I got from my previous step, and mgr theta. Similarly, when alpha is 30 degree, you get some relationship between mgr theta. Now you have two unknowns. One is r, the other is theta. You have two equations. You have to solve it. You will get the answer.
Sir, why is there no force at RA? F.
1 minute. Huh?
Tangential.
Why there is no normal force at RA? Are you saying that?
Tangential, sir. Tangential.
No tangential force because it is because the gear is only at B. There is no gear at A. This is a smooth contact. Only gear is causing the entire structure to move. There is no FA is actually like a roller.
Okay.
It is written the
Will
first
you
sentence.
please explain the gear once again?
Yes, I'm doing that.
Yes,
so the
sir.
first sentence is special jig consists of a 80 megagram sector mounted on a line of rollers at A. So since it's a roller, you don't have any tangential force. Now coming to our B, gear at B. First of all, try to imagine what the free body diagram of the gear will look like. We draw the gear like a circle, but it is actually not a circle. I mean, wait, let me show if there is some figure close to that. You can say that a gear will actually look something like this. Yeah, it has many teeth. Out of the auto shapes, this is the closest. Wait, let me take an image from Google.
Yes, we have seen gears.
So it was there in class 9.
In cycle.
So a gear actually looks like this. At A, the contact is something like this between the jig and the gear. When you have a contact like this, you will have a normal force and a tangential force. Because of the tangential force, when the gear will rotate, the other structure will also rotate. Okay, so this gear B is rotating, which will cause the entire special jig to rotate. So if I draw the free body diagram of the gear, I have a moment M that is applied, reactions RB and tangential force F, and the normal force. We have to find out the value of F. This is the important quantity for us. How will we find it? We will take a reaction moment about the center of this gear. So when you take the moment about the center of this gear, you should get an equation which says M is equal to F into R. So F is equal to M divided by 0.24. Yes or no? This is, I think, straightforward. M divided by 0.24. If M is counterclockwise, F direction that I have taken is right. If M is clockwise, then the F value will come out to be negative. We don't need to, I mean, when drawing the free body diagram, we are not considering this. I will always take F to be like this, but I will take the sign correctly. So F value you can get as M divided by 0.24. When alpha is equal to 0, M is counterclockwise, meaning F direction is right. When alpha is 30 degree, a counterclockwise torque has to be applied. So M is minus. Counterclockwise is taken to be positive. So this way you can get the value of F. When you get the value of, what is the value of F, so that my jig is in a state of equilibrium. If no torque is applied at the gear, the entire thing is going to rotate such that the G is passing through the centroid. I mean, because of the G, there is a tendency of the entire structure to rotate. The job of the gear is to prevent that rotation. When alpha is 0, the gear has to apply a counterclockwise torque of 2460 Newton meter. Otherwise, the structure is going to rotate. So if a counterclockwise torque is 2460,
So you are not audible again.
The voice is not coming.
So you are not audible, sir.
Hello? I was not audible for the last 5 minutes.
Last
Hello?
For a few
Now,
moments
now,
before.
So just for 30 seconds.
Out a minute
okay,
plus few seconds.
okay. So now I am
Only a
saying
few
that I'll repeat whatever I said. Okay. So if alpha is 0, the gear has to supply some torque for my entire structure to be in equilibrium. Similarly, when alpha is 30 degrees, some other torque has to be applied for the structure to be in equilibrium. In both the cases, the value of reaction RB and the value of reaction F will be different because the applied torque is different. Now, let us draw the free body diagram of the jig. It will look something like this. At A, you have F, RB, and you have mg, which is passing through the center of gravity. We want to find out the location of this.
So the whole structure is
Yes.
jig.
Whole structure is
Jig.
yes. The whole I'm drawing outline of the jig. The entire jig looks something like this.
Okay.
So
Sir,
now
why
let
is the
us
sector not applying force? Sector.
which sector? We are drawing the free body diagram of this blue one and this rectangle. The entire thing I am drawing it all at once.
Okay.
So the torque is applied at the gear.
Torque is applied at the gear, which is causing an internal reaction of RB and F on our special jig. Okay, so it looks something like this. I think this free body diagram in itself is straightforward. Reactions at A are A, mg, which is passing through the centroid of this body, and RB and F, which is the internal reaction due to the gear. We have to find out the point through which the centroid is we have to find out the center of mass. Center of mass has been characterized by R and theta. Now, when alpha is 30, if I take moment about point O, I will get some equation of equilibrium. For the second case, again, I will take equation about O. I will get some equation of equilibrium. I am taking equation about O because RA and RB will pass through O. So I only have F and mg as the two forces. Therefore, a relationship between the location of mg and F will come out to be straightforward. So I have these two equations. In both the equations, everything is constant. The variables are R and theta. From these two equations, you will solve it. You will get the value of R and theta. Okay?
Yes, sir. Got it, sir.
Yes, sir.
Okay. Anything else? I think then.
No, sir.
Then my equation becomes a bit
No,
troublesome.
sir.
Why don't we consider tangential force at B? We do consider the tangential force at B. Because 1 minute, what is he saying? We found out the Shaurya. We did P into 0.375 is 80. No. Wait, 1 minute, please. We did, which question are you talking about? Shaurya, what is your doubt? Question 11. But I was, sorry, I got confused about 11 and 12. I was talking about question 12. In 11, we don't do the tangential force because we look at the free body diagram of the entire structure. Rugved, what is your question?
So I had a doubt in the 2D equilibrium third slide, first question. Sir, I had posted the question earlier. Sir, about the tension of the rod.
Third slide, presentation number 1, is it?
Yes, sir.
But wait, we'll get there. So problem sheet 2, everything is clear. How many of you were able to do less than 6 questions in the tutorial 2 hours that we sat today? This is a very important question. Please give me honest feedback, okay? So how many questions did you do in this 2 hours?
Sir,
Whatever is the correct answer, please
5,
hit. Please hit.
So 6 to 9.
So 10
I have given
questions I
3
did,
options.
except
Please
11.
vote on the correct option, which is most relevant to you.
Around 9 questions.
I could do exactly 9.
Very good.
The 7 questions.
Okay.
Sir, I did
So
7 questions.
9.
And does everybody agree that this is a better way to conduct the tutorial sessions? That we give
Yes,
you
sir.
the problem sheet
Yes, sir.
just before the time,
Yes, sir. Yes, sir.
and 2
Yes,
hours
sir.
we spend.
Yes,
This
sir.
is much better
Yes,
than
sir.
giving
Yes,
you the
sir.
problem sheet before. Yes.
Yes, sir.
Yes.
Yes,
Yes, sir.
Yes, sir.
Sir, this is more
Yes, sir.
productive
Yes,
in
sir. This is the best
productive
way.
way of doing.
Okay. So from now till the end of this course, we will do this. Thursday night, I will send you the problem sheet. I will not send you before. And in the 2 hours, we will try to solve as many problems as we can.
Okay,
Yes,
sir.
sir.
So that
Yes, sir.
after the tutorials, you have very little work for the weekend. I mean, if you have done 9-10 questions, you just need to do 1 or 2 questions to complete this problem sheet. If you come to the tutorial sheet having done the problem, then you have nothing to do in these 2 hours, which is not productive.
Yes, sir.
Exactly, sir.
Sir, I had a doubt in question number 12.
Yes.
Sir, why is the system rotating at O? Shouldn't it rotate at the center of, at G, center of gravity?
It will rotate. If you don't apply any torque in the gear, it will start rotating about the center of gravity, which we don't want. We want the jig to stay as it is. That's why we are applying a counter torque in the gear to prevent that.
So we are making the jig rotate at O.
We don't want the jig to rotate at O. No, it will not rotate about O. It will rotate about the center of gravity. We don't want that rotation.
Okay, sir, got it.
I mean, there are two forces. One, the jig wants to rotate due to its own inertia, and the other is counterbalancing. We are applying some torque to avoid that.
Sir, hello.
So, question
Yes.
number 12 is of statics or dynamics, sir?
Statics.
Sir, but
Sir, I have
actually,
a small
in
doubt
this
in question number
torque is
5.
acting. When we talk about torque, it is in dynamic. In statics, we talk about moment, no, sir?
Yeah, some wording problem. What does it say? A counterclockwise. Yeah.
Sir,
Technically, you are right.
number 5, sir.
Overall, it is not moving.
Hello.
Hello,
Yes.
sir.
Yes.
Sir, I have a doubt in question number 5.
Question 5.
Yes, sir.
I have doubt in this question.
I think now the problem is the tutorial session is 2 hours is over. I have to go.
No, sir,
somewhere
I
else.
have another doubt, sir. Just a concept.
I can't go back. So try to solve it. Try to contact your friends.
Sir, okay.
Sir, the second assignment for mechanics will
That's why I want to finish this by making some announcements. Okay. Announcement number 1. Your Moodle marks should have been out for your assignment number 1. I hope all of you have checked Moodle and you have found out your marks. This is number 1. Number 2, if you have any problem, you should tell us before the deadline. Moodle is not working. I was not able to log in. This question was not visible to me. Any technical problem that you have in Moodle, that should be reported before the deadline. If you report after the deadline, then we start suspecting. That is normal human tendency. So if Moodle is not working, or if you forgot your password, or if there is any technical issue, if you tell us before the deadline, we can do something about it. If you don't tell us anything, if I ask you and then if you tell me, that is not right. Correct? So if you have any problem, you have to tell us before the deadline. This is second. Third, there will be a assignment number 2, which should be out today. Okay. And normally in that assignment also, there will be a workout problem. And that workout problem will have to be uploaded in MS Teams. You are expected to write down or take a snapshot of the workout problem when you are solving the problem in Moodle. Because once the deadline for Moodle is gone, you cannot go back and try to find out what your question was. It is when you are solving it, please make sure to take a snapshot. Otherwise, you will miss the MS Teams submission. Okay. And in question number 1, for the benefit of all, the tolerance was taken to be 0.04. Not 0.02 as you wanted, but it is 0.04. So I think checking wise, nobody should have any complaint. Correct?
I have a doubt in question number 4 of the assignment 1.
That I think I have received. So question number 4 and question number 3, some of you have raised doubts. I will relay your doubts to the person who set up the question paper. You will get some clarification soon.
Okay, sir. Thank you.
Question number 4 was the workout problem, or was it some other problem?
No, sir. Some.
No, sir.
No, sir, it
It was
wasn't.
not
The
workout.
workout was the question number one.
That was problem number 1.
Okay. Okay. Take it. Okay, good. Anything else?
Sir,
So these are the important announcements I wanted to make. Yes. From now, anything you want to say, you can say.
Sir, what is the deadline for assignment 2?
I am not sure. Either it is Saturday night or it is Sunday night. It will be one of the two. Just like last time, there will be 3-4 questions.
Sir, the mock assignments, anything is given, number or marks?
No, the mock assignment had no weightage. It was meant so that you get acquainted with Moodle, you get acquainted with how to submit assignments, so that everything is done. That's why it has no weightage.
Okay, sir.
So where we have to submit the assignment to?
Assignment 2 you will have in Moodle, as well as there will be a workout you have to submit in MS Teams. I will set up an assignment soon.
Okay.
Sir, can we log in module assignments multiple time?
I think so.
Thank you, sir.
In exam, you cannot do that.
Thank you, sir.
Okay, I think then can we wind up this meeting?
Sir, where we can show the result of assignment 1?
Please go to